Welcome back. For the next three lectures, including this lecture, we shall solve examples based on bending or flexural stresses in beams. In the first of the examples, we have a symmetrical section 200 millimeters deep and has an area moment of inertia 2.26 times 10 to the power of 5 in meter raised to 4 units about the neutral axis. It is required to determine the longest span over which, when simply supported, the beam would carry a uniformly distributed load of 4 kilonewtons per meter for the entire span if the stress due to bending does not exceed 125 meganewton per meter square. This problem is normally asked for 4 or 5 marks and is relatively simple to solve. We begin by first writing the given data with the corresponding symbolic notations. Since the depth is given as 200 millimeters, hence the value of y, that is the distance of the fiber having the maximum bending stress, which is at the farthest distance from the neutral or centroidal axis, is 1/2 of this depth value, that is 100 millimeters. We convert this to SI units of length for convenience. Likewise, we add other given data to the list. It is required to estimate the maximum value of the length in meters so that the maximum given bending stress is not exceeded. We recall from the last chapter that the maximum bending moment induced in a simply supported beam of length L meters carrying a uniformly distributed load of W kilonewton per meter is given by W times L squared over 8. Implementing this in the part of the flexure equation, we have W times L squared over 8 divided by area moment of inertia I equals the maximum bending stress, that is sigma x max over y. Hence the length is found out as 7.5166 meters and is the answer to the given problem. After having seen a fairly simple problem, we shall try to solve a bit more complex problem on bending stresses in the next couple of lectures.